In this lesson, we're going to take a look at properties of logs. So here we have some basic properties of logs. Next time we see properties, they'll be a little bit more complex. So our first rule or property of logs is any log base A of 1 equals 0, and think curly law because any number to the 0 power equals 1. Our next rule, we have log base A of A equals 1. Again, thinking curly law, because any number to the first power equals itself. Third rule, log base A of A to the x power equals x, because, now this one, the curly law is a little bit more complicated to follow, so I'm going to draw it out for you. This A base A to this x power, so that's our first one right here, equals, curling back around, A to the x power, so that's the one over here. Now another property, this one's actually kind of a property of exponents, but what it really is the property of inverses, that logs and exponentials undo each other. So we've got this complicated looking expression right here that says an exponent base A raised to the power of log base A will equal x, because exponentials and logs undo each other. And our fourth property is log base A of x equals log base A of y, then x equals y. And that's just a property of equality. Hopefully that makes sense to you, seems a little bit straightforward or common sense. What we're going to do next is practice evaluating logs. Some of those properties we'll use, some of them we may not. You might see some of them on your assignment instead. So we are starting with log base 4 of 1. So anytime I'm evaluating a log, I think the curly law. So if it helps you to set it equal to a variable, and then use the curly law, 4 to what power equals 1. And if you want to write it in exponential form, you can do that as well. 4 to what power equals 1? The answer is 0, because any number to the 0 power equals 1. So make sure you understand that log base 4 of 1 equals 0. That's the expression that we are evaluating. Next one, we have log base 49 of 7. So again, curly law, if you want to set it equal to a variable, we'll do y this time. Any variable will work. 49 to what power equals 7. So writing this in exponential form, sorry, my 9 kind of looks like a G. 49 to what power equals 7. So some of you may be thinking, well, 7 squared equals 49, but I don't know what power of 49 will give us 7. The square root of 49 equals 7. So remember, when we write that as a rational exponent, it is the 1/2 power. So again, make sure you understand, make that connection. I want you to write this down so that you can start to understand the connection between logs and how to evaluate them. So log base 49 of 7 equals 1/2. Also listen to how I'm reading logs. I've read them several times now. I have a lot of students that don't read logs properly, so make sure you understand how to read the log. Next one I'm going to read to you again, so listen carefully. Log base 9 of 9 to the 4th power. So this one's the inverse property of logs and exponents. We have a log base 9 of an exponential base 9, so they cancel each other out, leaving you with just the exponent, or 4. So log base 9 of 9 to the 4th power equals 4. The next one is our kind of our common sense property of logs. If you have two logs with the same base equal to each other, essentially you can drop the logs. What we're really doing to show you how we're solving the equation, how we're getting those logs to cancel, is we're turning both sides into the exponent with a base of 4. So we're using the inverse property for logs and exponents. Base 4 to the log base 4 power cancel each other out on both sides, leaving us with x plus 1 equals 8. And of course, subtracting 1 from both sides, we get x equals 7. And our final example for this lesson, we have log of 1/100th. Remember, when we don't see the base, it's the common log. So we have log base 10. So if you want to do your curly law, 10 to what power gives you 1 over 100. So this is one where we have to think about, how does the base become a denominator? Well, 10 squared gives us 100, and a negative would put it in the denominator. So x equals negative 2. Rewriting this one with the log of 1/100th equals negative 2, because 10 to the negative 2 power equals 100. Your U-Tries for today are to write 2 questions and a quality summary. This lesson was relatively straightforward and hopefully simple enough that you can understand it. So what I really want you to focus on is writing those left-hand questions and a summary, and practice that with maybe an easier topic, and we can go over those tomorrow together.